Welcome back to the deep dive. Today, we are doing something that might make a few of you inadvertently clench your jaw. We're going to talk about Haskell.
Haskell, the final boss of programming languages.
Exactly. The reputation is it's massive. You mentioned Haskell, and people immediately picture whiteboards covered in Greek letters, category theory, monads, PhD theses.
It's seen as the ivory tower language.
Yeah, the language you learn to prove you're smart, not necessarily to get work done.
And that is exactly the stereotype we are going to smash today. Because we aren't looking at a textbook. We aren't looking at a purely academic paper.
No.
We are looking at the notes of a self-described old software plumber.
I love that title, software plumber. It creates such a different mental image than, like, functional programming architect.
He does.
It feels grounded. It feels messy.
And it is messy. We're analyzing a specific blog post from kionmal.org published just recently on February 5th, 2026. The title is Notes on Haskell Programming, Part 50. Fixing Type Mismatch Errors in DoBlock.
Part 50. That implies a pretty serious commitment.
A very long documented journey.
Yeah.
So our mission today is to look over the shoulder of the author, Ang, as he debugs a specific, really annoying compiler error.
Okay.
We're going to understand why the error happened, how he fixed it, and frankly, why looking at code as plumbing is actually the best way to understand a complex language like Haskell.
So just to be clear for everyone listening who might be sweating a little, no math equations today.
Zero equations, just pipes, leaks, and adapters.
Perfect. Let's get into the context. What exactly was Ang trying to build when the plumbing burst?
So he works on this console application called XS2 ebook. It's a handy little tool that takes RSS feeds, like news feeds,
Yeah.
and it converts them into an ebook format.
So you can read them offline.
Exactly. It's a classic utility script. Takes text in, spits an ebook out. Very practical.
Right.
And he was in the process of updating it. He needed to add a new argument to the command line interface. Like when you run a program and you add verbose or output file name.
Okay, so he was just wiring up that new connection.
Simple enough. Software plumbing 101.
Yeah.
You need a new pipe for a new input.
Right. But when he tried to compile the code after adding this new argument, the Haskell compiler JHCTAJ, it didn't just politely decline, it threw error GHC 83865.
What sounds like a citation from a futuristic police force. Citizen, you are in violation of code 83865.
So what was the crime?
The crime was a type mismatch. The specific error message was, couldn't match expected type IO Args with actual type Args.
Okay, let's pause there and unpack that. Couldn't match expected type. This is the classic square peg in a round hole scenario.
Precisely. But to understand why the peg didn't fit, we have to look at the function he was writing. It's called parse CLI.
Parse CLI. So this is the function responsible for reading those command line flags we talked about.
Correct. And in Haskell, every function has a signature. It's like a contract. It tells the world, this is what I take in and this is what I give back.
And the signature for parse CLI was defined as returning IO Args.
IO.
So I get that Args is the data, the arguments themselves. But why is it wrapped in IO? I mean, why not just return the Args?
This is the concept that trips up almost everyone, coming from languages like, Python, Java, JavaScript. Haskell is a pure language.
Right.
It strictly separates the thinking from the doing.
Thinking from the doing. Okay, break that down for me.
Thinking is pure calculation.
Yeah.
2 + 2 is always 4. Doesn't matter what time it is. Doesn't matter if the server's down. It's just math. That's pure.
Okay, so that's safe, predictable.
Right. But reading from a command line, that's doing. That interacts with the messy outside world. The user might type garbage. The terminal might not exist.
The computer might be on fire.
Right. It's unpredictable. It's impure.
Yeah.
So Haskell forces you to wrap that interaction in a safety bubble called IO.
I like to think of it like a hazmat suit.
That's a perfect analogy. The args are contaminated by the unpredictability of the outside world, so they are sealed in an IO hazmat suit.
Yeah.
You can pass the suit around safely, but the compiler tracks it, very strictly.
You can't just let the radioactive material touch your pure math code.
You can't. So parse CLI promised to deliver this sealed hazmat box containing the arguments.
Okay, so where did Ang go wrong?
Let's look at the code he wrote inside the function. He used something called a do block. It looked like this. Line 12 was result, custom xparser or argparser prefs, argparser info.
Okay.
And then line 13 was just result.
Okay, walking through that. Line 12 calls a parser function, saves it to a variable called result. Line 13 just returns result. I mean, if I typed that in JavaScript or Python, that would be totally standard.
In those languages, yes. In those languages, there are no hazmat suits. Everything touches everything. But look closely at line 12. There's a symbol there,
The left-pointing arrow.
the arrow. The source calls this the binding arrow.
What's it actually doing mechanically?
This is the pivot point of the whole error. The function on the right, custom exec parser, that actually does return a seal box. It returns IO Args.
So we have the box, we have the hazmat.
We do, but the arrow, ADO, is a specific tool designed to unwrap the box. It executes the action, reaches inside the hazmat suit, pulls out the raw args, and assigns that raw value to the variable result.
Oh, I see. So the variable result isn't the box anymore.
Right.
It's the naked data inside.
Exactly. The arrow effectively strips the IO wrapper, so now result is just of type args.
And then on line 13, he just writes result. He tries to hand that raw args back to the main program.
And the main program, the compiler, it checks the contract. The contract said, I promised to give you a sealed IO box, but the code says, here's the raw data.
I expected a container. You gave me the contents.
And GHC says, absolutely not, type mismatch. I cannot touch that raw data.
It's funny because in his head, he probably just wanted to get the value, but the arrow did a little too much work.
It did. It unboxed something that was supposed to stay boxed. It's like opening a package from Amazon, taking out the item, and then realizing you were supposed to forward the sealed box to your neighbor.
And now you're standing there with the item in your hand, and the neighbor won't take it because it's open. So how does a software plumber fix a leak like this?
What I love about this blog post is that Ang doesn't just give one fix, he explores three. It's a great tour of how Haskell handles these wrappers.
So let's start with the one he actually used, the simplification method.
This is the most elegant solution. He looked at the code and realized, wait a minute, custom exec parser gives me an IO Args box. My function needs to return an IO Args box. Why am I touching it at all?
Right. Why unwrap it if the next guy wants it wrapped?
Exactly. So the fix is delete the arrow, delete the result variable, just make parse CLI equal to custom exec parser.
Just connect the pipes directly?
Direct connection, no intermediate step. If you have the package and the recipient wants the package, just hand them the package. Don't open it.
That is so satisfyingly clean. It makes you realize how much unnecessary code we write sometimes just out of habit.
We do. We feel like we need to hold the data before passing it on. Haskell teaches you that often you're just a conduit. You're just a section of pipe.
But he mentioned two other ways. Why would you ever not use the simple way?
Well, imagine if you needed to do something with that data before you returned it. Maybe you needed to log it to a file or check a value inside it to decide what to do next. In that case, you would need to unwrap it using the arrow to look at it.
So let's say we had to keep the do block. We've unwrapped the data into result because we needed to inspect it. How do we fix the error now that we're holding the raw data?
We need a way to rewrap it. We need to put it back in a hazmat suit. And this brings us to the second solution, the return function.
Return. Now, I have to stop you because I know return in Java or C or Python, it means stop the function and exit immediately.
Huge distinction here. In Haskell, return does not stop execution. It doesn't mean exit. It literally means encapsulate. It takes a raw value and wraps it into the IO context.
So it's a packaging machine.
Yes. So the code would be line 12, extract the value with the arrow. Line 13 would be return result.
Open the box, take out the item, and then put it into a brand new box.
Which seems redundant in this specific case, which is why the first solution was better. But mechanically, it satisfies the type checker. Return result creates a new IO Args package, so the function fulfills its promise.
Okay. And the third solution, the source calls it the modern and idiomatic approach.
This involves a function called pure. So instead of return result, you write pure result.
Pure. That sounds very virtuous. I am purifying this data.
It does, doesn't it?
Yeah.
In this context, pure and return do essentially the same thing. They both lift a value into a context. Pure is just the more modern generalized version.
Okay, we don't need to go down the whole applicative rabbit hole, do we?
We do not. Just know that in modern Haskell style guides, pure is often preferred. But for our plumber Ang, the solution was clear. Solution 1, just remove the clutter.
So he deletes the do block. The parse CLI function is fixed. It's sleek. It's compiling. He hits run.
And then another leak springs.
The ripple effect.
The ripple effect. This is the reality of strict typing. You fix one joint, the pressure moves down the line, and the next week, joint bursts.
Where did the new error pop up?
In main.js. The entry point of the entire application, the error was couldn't match type xs2 ebook.cli.args with...
That funny little... That's an empty tuple, right?
Yes, pronounced unit. It's Haskell's version of void or nothing. The main function was originally written to expect parse CLI to do its job and return nothing meaningful, just an empty action.
But we just changed parse CLI.
We did. We changed it to return IO Args. So now, main calls parse CLI and suddenly finds itself holding this heavy box full of arguments.
And it has no idea what to do with it.
It's a literal shape mismatch at the connector. Main expected a void action, IO, but it got IO Args.
It's frustrating, isn't it? You fix one thing and break another. It feels like whack-a-mole.
It feels frustrating, but consider the alternative. In a language like Python or JavaScript, this might run fine until the program actually tries to use the return value that it didn't expect to exist and crashes at runtime. Or worse.
Or worse, it silently ignores it and you spend 3 weeks wondering why your arguments aren't working.
Exactly.
Ugh.
Haskell is forcing consistency across the entire web of pipes. You cannot change the diameter of one pipe without updating the fittings on the next one.
So how did Ang resolve this final standoff?
He had to update the contract of the main function. He imported the args definition and changed the signature of main to accept and handle that IO args return type.
He acknowledged the data flow. Okay, main, you are now responsible for this data.
Correct. Once he aligned the signatures, parse CLI delivers args. Main accepts args. The compiler was happy. Green lights across the board.
And Acts 2 book is back in business.
Back in business and safer than before.
You know, walking through this, I'm realizing that the plumber analogy isn't just a cute nickname. It's actually a really healthy way to think about coding. It removes the ego.
It does. It's not about, I am a genius architect creating a masterpiece. It's, does this connect to that? Is there a leak? Is the pressure correct?
And speaking of that mindset, we need to talk about the rest of this blog, because when we were prepping for this guide, you showed me the sidebar on qianmeng.org, and my jaw just hit the floor.
It is a treasure trove. It completely recontextualizes the technical stuff we just talked about.
Journal of an old software plumber. But tell the listeners what else is in that sidebar.
It's an archive of a life lived with extreme curiosity. We're looking at Notes on Haskell Programming, Part 50, which is impressive.
Yeah.
But right next to it, Notes on Gardening, Part 798.
798. Notes on Gardening.
Notes on Fish Keeping, Part 187. Notes on Photography, Part 228. Notes on Dieting. Notes on Guitar.
This isn't just a tech blog. This is an everything blog.
It's a tinkering blog, and I think this context is crucial to understanding how he solved the Haskell problem.
How so? Connect gardening to compiler errors for me.
Well, think about betta spawn logs. That was one of the subcategories. If you are breeding fish, you have to track water temperature, pH levels, lighting, food. You tweak one variable, observe the result, and you document it.
It's a system.
It's a complex, interconnected system where inputs affect outputs, just like a Haskell program.
So when he hits error GHC 83865, he doesn't throw his keyboard. He treats it like a wilted leaf.
Exactly, a wilted leaf. Why is this leaf brown? Is it too much sun, too little water? Why is this type mismatching? Is it wrapped? Is it unwrapped? It's the same muscle, the muscle of observation and adjustment.
That is such a powerful reframing, because I think a lot of people, when they learn a hard language like Haskell, they feel stupid when they get an error. They feel like, I'm not smart enough for this.
Right. But Ang shows us that it's not about being smart. It's about being observant. It's about patience. Writing Part 50 about a relatively minor syntax error takes humility.
Most developers only blog about their triumphs.
Yeah, how I built a scalable cloud architecture. They don't blog how I spent 4 hours fixing a type mismatch because I forgot to unwrap a box.
But Ang does. He learns in public. And because of that, thousands of other plumbers who hit that error will find his note and fix their leak.
Learning in public. That's a phrase I hear more and more. It's scary, though. It feels vulnerable to put your mistakes out there.
It is scary. But look at the volume of his output. 800 notes on gardening. You don't get to note 800 by waiting until you're an expert to write something down.
You become an expert by writing the 800 notes.
That's the takeaway right there. The documentation isn't the result of mastery, it's the mechanism of mastery.
Precisely. He didn't write the note because he knew the answer. He wrote the note to solidify the answer for himself.
It really makes you look at your own browser history differently. How many problems have I solved this week that I've already forgotten?
And how many will you have to resolve next month because you didn't write a note on Project X, Part 1?
Ouch. Too real. I usually just rely on muscle memory and panic.
Panic is not a strategy. Documenting is.
So, to bring it all back to the code, we started with a scary error in a scary language. We learned that the left arrow is a tool for extraction, taking the dangerous data out of the IO hazmat suit.
We learned that if your function promises a suit, you better deliver a suit. And we learned that the cleanest code is often the code that does the least.
Just passing the box along without opening it. And we learned that fixing a bug in one place acts like a ripple in a pond or a pressure wave in a pipe that can expose issues elsewhere.
And finally, we learned that the mindset of a gardener observation, daily tending, and documenting the small stuff is the secret weapon of a great software engineer.
It makes the term software plumber sound pretty dignified, honestly. It's not about glory, it's about flow.
It is. It's essential work. It keeps the information flowing. Without the plumber, the house floods.
Before we go, I have to ask, do you think he treats his gardening with the same type safety rigor as his code?
I bet he does. Expected, tomato, actual,
Right.
weed, error, garden 404.
I would read that deep dive notes on why my hydrangeas aren't compiling.
You know, it leaves me with a final thought for you, for the listener. We often look for the best resource to learn a new skill, the perfect book, the perfect course. But looking at Ang's sidebar, it raises a question.
What's that?
If we all treated our professional learning like a spawn log, documenting every tiny error, every misunderstanding, every small fix, how much faster would we actually master our tools? Are we struggling because the tools are hard, or are we struggling because we keep solving the same problems over and over without ever writing them down?
That is something to chew on. Maybe it's time to start Notes on My Life, Part 1.
I'd subscribe to that.
Thanks for listening, everyone. Huge thanks to the Old Software Plumber for the lesson in Haskell and Intelligence. We'll see you on the next deep dive.
Happy coding!